Hello everyone, welcome to the next lecture on the GATE mathematics. Today I will cover all those questions from the year 1996 to 2023. I will choose the topic as an initial value problem. Myself Dr. Harish Garg. You can simply follow my YouTube channel where you can find the playlist of the GATE mathematics and you can see there is a question related to the topic wise of GATE 2019, 22, 18, 17 all are available in this playlist. Apart from that, there is one more playlist is a PY question of the CSR net and gate, and here you can find the vector calculus, exact differential equation and many more is available in this playlist. So let's start with this one. So before I start with this PY question series, let me quickly give you some shortcut tips so that you can solve this question in a very simple manner. Whenever you are talking about the initial value problem, the differential equation is either the first order or the second order. If you have the first order differential equation and the initial condition is given at the point t naught, if you prove that the coefficient of the pt and the coefficient pt and the gt both are my continuous in the neighborhood of my t naught, that is my initial vector x naught, then this initial value problem will give you the always unique solution in this interval a comma b. It may happen that instead of the closed interval, it may have an open interval. Then your option will also be as a open interval. The same concept we can apply for the second order differential equation. Here the coefficients are p, q and g. If all these coefficients are my continuous in the closed interval or the open interval containing the initial point t naught, then it will give you the unique solution. However, if you have the since these two conditions are given at the point t naught, so these are my initial value problem. However, if you have initial value problem at y is given something and the value is given at some another point b, then we call as the boundary value problem. Now if you are the two initial value problem or the two boundary value problem are given to you for the second order differential equation, then it always give you a unique solution. If only one condition is given to you, like if only one condition is given to you in this second order differential equation, then you have the infinitely many solution of the form one parameter family of curve. If no condition is imposed on this, like if no condition is imposing on this, then you always has an infinite number of solution in the two parameter family of the curve. Now from this here we can see when we will get the unique solution. But what about the others? That is a no solution or infinitely many solution. For that case, we will consider the existence case. If you prove that this function f is my continuous, then there is a guarantee of at least one solution. And if you prove that this del f upon del y, this is my bounded, what does it mean? That means if you prove that f will satisfy my Lipschitz condition, then you can say the unique solution will exist. Or another word, if you prove that f and del f by del f both are continuous, then you always say a unique solution is existence in the neighborhood of x naught. On the other hand, if you prove that del f by del y is unbounded, then you have either a no solution or infinite many solution. So what is the simplest way you can think about that? If you have a first order differential equation like of this and the initial condition is given to you by this, then you can say you always check about this case. Fine. If you prove that it is bounded or it is unbounded, there are the two cases. If you prove that it's a bounded, then it always give you a unique solution in the neighborhood of x naught. If you have an unbounded solution, then you have the two cases, either it has a no solution or infinite many solution. So that's the simplest way you can remember initial value problem. If you prove that it has a solution, then how you can find the existence? You can see this is the simplest way, as I think all of you know that a is my upper bound, b is my here, about the initial solution x naught and y naught, m is my maximum of this. This will give you the interval of this nature minus h2 plus h. If you prove that f is my bounded, this f is my bounded and continuously differentiable, then there is no need to find this case. In that case, the complete real line will be my interval of existence. The last shortcut tips for you, whenever you have a first order differential equation, this is a very important tips for you. If you are the student of the GATE examination, either you are the student of the CSR NET examination, or either you are the students of the IIT JAM or any other competition exam where this differential equation is a part of the syllabus, definitely one question will be asked from here. If you prove that this alpha will lies between the 0, 1, B is any real number, then there are two cases whether A is my positive or negative. If A is my positive and C will be my 0, then you have infinitely many solution, and otherwise it's a unique solution if it is a positive. On the other hand, if A is my negative, then C is equal to 0, you have a unique solution. That is the opposite of this case. So based on these shortcut tricks, I can solve all those questions in a very simple manner for you. So let's start with the PY questions. So before that, you can simply scan and join this WhatsApp code. You can join with me through my WhatsApp group. Okay, the initial value problem has a unique solution. What I told you, when it will be have a unique solution, if you prove that, this will be my bounded. Fine. So if you compare them, what will be your f? F will be 2x minus 1 y over x square minus x. Make sure the coefficient of this should be 1. Now can you find the value of this? So the value of this will be 2x minus 1 over x minus 1 when it will be bounded. Fine. When it will be bounded, collection of all those are apart from 0, 1, because at 0, 1 this solution is unbounded. It means this value is not 0, x0 will not be 1, then it will give you a unique solution. So you can see this value is 1, so this option is cancelled, this is 0 cancel, this is 0 cancel, right option is my A is the right answer. You can see there is no need to solve them. Some student may think about they can solve like this way, like x square minus x, then integrate, then find the solution. Why there is need of them? Simply apply the concept of the unique solution. Look at this another one. Y dash is y of 3 by 5 and y naught is my b. So clearly say this number is belongs to the 0, 1. Coefficient is my 1 which is greater than 0. Then what is the case? If b is equal to 0, you will get as infinitely many solution. If b is my strictly greater than 0, then you will get as unique solution. Fine. That is the shortcut tips as I told you. Now look at the option. B is equal to 0, infinite solution, but he said unique solution. B is equal to 1, which is a greater than 0, so we will get a unique solution, but he said no solution. B is equal to 2, which is greater than 0, we get a unique solution, but he said infinite many solution. B is equal to 1, which is greater than 0, unique solution is the right answer of the problem. Again, student may think about like they can solve like of this way. Why there is a need of solving like this manner? They are not asking you about the solution. You have to apply the concept. Now look at this another case. Again, they are not talking about the solution. What is that? If I write in this equation y is equal to a m plus b, and your target is to prove y will goes to the 0 as x will goes to the infinity. Very simple. Look at the first option. A is greater than 0, b is greater than 0. Choose any a and any b. I can choose a and b such that I can factorize them easily. I can choose a is equal to 3, b is equal to, or simple ways, I can choose a is equal to 2, b is equal to 1. Fine. Or you may choose as a is equal to 4, b is equal to 5, for example. So then it will be plus 4m plus 5. So your solution will be m plus, no, the solution will be complex number. So I can choose any other so that I can solve it easily. I can choose here, what is my this? It's a m square plus 2m plus 1 is 0. So my solutions are minus 1, minus 1. So y will be c1 plus c2x e raised to power minus x. So clearly say when x approaches infinity, this value will goes to the 0. So this option is my correct option. A is my greater than 0, b is my less than 0. I can choose a is my 2, So m square plus 2m. B is my negative, so I can choose such that I can factorize them. 3. So my factor will be m plus 3, m minus 1, 0. So solution will be c1 e raised to power minus 3x, c2 e raised to power 1x. So clearly say this value will goes to the 0, but this value will goes to the infinity. So complete term will goes to the infinity. So this option is cancelled out. Look at the third option. A is negative, B is negative, B is my negative. So both value I can take as a negative. So what I can choose, I can simply take this value. So my factors are m minus 4, m plus 1. So my solution will be c1 e raised to power 4x, c2 e raised to power minus 1x. So this value will goes to the infinity, this will goes to the 0, complete term will goes to the infinity, but we need a y0. 1 A is negative, B is my positive. So A is my negative, I can choose as a 3m, B is my positive, I can choose as a 2. So my factors are m minus 1, m minus 2. So solution will be e raised to power 2x, c2 e raised to power 1x. So clearly say both will goes to the infinity. So this option will be cancelled out. So my right answer is A is the only right answer of this problem. Okay, now again you can see they are not talking about the solution. They are checking about whether the unique or here. Again, I can apply the concept initial value problem. Fine. What is f del f by del y? This is minus x sine of xy. So if I take the modulus, it will be less than of mod of x, and over this bounded interval it will be less than of a. That means this is bounded. Once it is a bounded, what does it mean? It give you a unique solution. So that's the right answer of this problem. Hardly a 10 second you are needed to solve the problem, if you remember the concept as I told you. Again the initial value problem is given to you, and again you can see they are not asking you find the solution. They are simply asking you whether the unique solution or not solution. What is my f in this case? Y plus x square over x. Fine. So what is that? Del f over del y. It is 1 over x. So what is that? Del f over, this is my 1 over x. Now clearly say which is not defined at initial point x naught. What does it mean? This means it is my unbounded. So once it is unbounded, it means it can never be a unique solution. Now once it is unbounded, there are the two options, either the no solution or infinitely many solution. But you can see one solution is already given to you. One solution is already given to you. It means no solution will be cancelled. Only infinitely many solution will be the right answer of this problem. Fine. It's a very simple. You can simply think about that. There is no need to solve this problem like this manner, like y over x is equal to x. Then you can find the integrating factor and so on. There is no need of them, because they are not asking you find the solution of the problem. They are simply ask you how many solutions exist. Again, there is no need to find the solution. They are asking you about the solution. So I can write this equation is y double dash 1 over x y dash plus y is equal to 0. Now clearly say the coefficient 1 over x, this is my 1 and this is my 0. These are my continuous, but this value is not continuous at 0. And check whether 0 is the initial point. Yes, this is my initial point. It means unique solution will not be there. Fine. So that will be cancelled out. If it is not a unique solution, it means either it has a no solution or infinitely many solution. Fine. How you can check about that? You can see y of 0 is my 1, y dash of 0 is equal to 0. If it is an infinitely many solution, can you find any of the solution which satisfy this property? It will never be there, because the derivative will be 0 and the function will be 1. It can never be there. What does the meaning of the derivative? First derivative 0, saddle point. Fine. It means infinitely is not possible. So the no solution will be here is the right answer of this problem. there does not exist any y which satisfied these properties from here. Now you can see here is that they are asking about the solution, so we have to solve them. But again, there is no need of solve them. I will tell you again the simplest way. Without the solving, you can solve them. If this is the solution of this problem, can you identify what is that? This is the complementary solution and this is my particular solution. That means this is the solution corresponding to the homogeneous part. What does it mean? If this is a solution corresponding to the homogeneous part, it means 2 and minus 2 are the roots of homogeneous solution, like m square plus beta. These are my homogeneous. So if I substitute here, 4 plus beta will be 0. So beta will be my minus 4. So this is the only right answer of this problem. Fine. But how you can find the value of alpha? Again, there is very simple. Alpha is related to the pi, but there is no need to find the pi. I can use this value of this and the initial condition. What is my y of 0 from here? 3 plus 1 minus 0, which is a 4, satisfied. What is a y dash of 0? If I take that derivative, it's a 6. I take that derivative is a 2. I take that derivative is alpha, which is equal to 1. So you can see 6 minus 2, 4 minus alpha is 1. Alpha will be my 3 is the right answer. You can see C is my right answer. No need to solve this problem. Just try to look about the concept. The solution of this, it means they are talking about y. The y does not exist. Fine. So again, I think very simple. I can simplify this. I can integrate them. Minus 1 over y, x plus c. Initial condition, y naught is my 1. So what does it mean? C will be my minus 1. So 1 over y is x minus 1. Y is minus here. So what does it mean? When it does not exist at x is equal to 1. Fine. It does not exist at x is equal to 1. Now look at the options. If you look about the last option, 1 belongs to that because a is my greater than 1. This option cancel. No, sorry. We need a does not exist. So it means this option is correct. 1 also belongs to this is also correct. 1 also belongs to this option correct. 1 does not belongs to this. So this option is cancel out. B, C and D are my right answer. Or you can say somebody asks you the solution will exist for what y, for what interval. This is my interval for which the solution exists. Or how you can find the solution? Other way you can find the solution is h is my minimum of a comma b over m, where m is my maximum of y square. What is the maximum of y square? On this case, x minus 0 is less than a, y minus 1 is less than b, so it will be 1 plus b square. If I substitute here, again you will get the same result. Okay, now again you can see from the options, none of the options will ask you about the calculation part. They are simply look about the logic. Here, fine. This is my f. What is the del f over del y? Minus 2y y square. So we will check whether what is the solution of this is a 2y e raised to power minus y square, which is a finite number. Fine. Why? Because, or you can say it's a bounded because of this negative sign in the neighborhood of y is equal to 0. It is a neighborhood of this. Because of this negative, it is always be the finite number. Once it's a bounded, what is the meaning of that? It gives you a unique solution. And what will be the unique solution? One solution is given to you as here. This is my one solution given to you, and it is a unique solution. What does it mean? Y of x is a 0 for all x is in my domain, whatever the domain. So what is that? Y of x is greater than 0 is wrong option, less than 0 wrong option, changes sign wrong option, only D is my correct option. If they ask you find the solution, then you have to solve it, but they are not asking you find the solution. They are just about the concept. Now they are asking you find the solution. So I think it's a very simple. Whenever it's a initial value problem, always find dy over dx firstly. So what is the value of this? I can write this equation of this nature. Fine. Now what is the integrating factor? This is e raised to power minus 1 over x into dx. So what is that? E raised to power log x is a 1 over x. So what is my solution? Y into here x into 1 over x plus c. So what is my solution? Y over x is x plus c. Now y of 1 is my 2. What is my c? 2 over 1 minus 1. C is my 1. So what is my y is x plus 1 into x. Now your target is to find the 2. 2 into 3. This is my 6 is the right answer of this problem. Always remember, whenever there is an initial value problem, always write the dy by dx firstly. Okay, look at that. Y is the solution of this, and now they are asking you the solution. So you can have to solve them. Again, integrating factor is e raised to power 1 dx, e raised to power x. So y, e raised to power x, integration of mod x, e raised to power x of dx. Fine. Now the initial condition is also given to you. So what I can do, plus c. So plus c, that c I can found from the minus 1 interval. So what I can do, I can simply write, instead of here, I can simply write this is y minus initial value problem. Y is equal to cx. Fine. Or you can say it will be like e raised to power x into yx minus y of minus 1. Fine. Or that c is, there is no need. Now what is the y of minus 1? Is a 0. So my solution is y into e raised to power x. I can break from minus 1 to x. Now your target is to find the value at the 1. So what is the value of at 1? I can substitute here y. So I can break them from minus 1 to 1 plus from 0 to 1. Fine. Now I think it's a very simple. Minus will be outside. Integration of this will be x minus 1 e raised to power x from 0 to minus 1. It will be x minus 1 0 to 1. So it will be minus. When it is a 0, it's a minus 1. When it is minus plus 2 e raised to power minus 1 plus 1 will be 0, minus plus e raised to power 0. E raised to power 0 1. If I open this, it will be 2 minus 2 over e. So what is the value of the y? 2 over e minus 2 over e square at the point x is equal to 1. So A is my correct answer of the problem. Again, this is the first order differential equation. I can firstly find dy over dx. So which is y plus x square plus y square over x. Now it is not a linear, but if you look about that, what kind of the solution is there? This is the homogeneous solution. So whenever this is a homogeneous, we can substitute y is equal to vx. So what is the left hand side? dv over dx, which is v. This is 1 plus v square. X will be cancelled out from the numerator. So v will be cancelled out. dv over 1 plus v square. This is my dx over x. Now what is the integration of this? Is ln of v plus 1 plus v square. This is ln of x into ln of c. So, or now the constant is my k, so I can say it's a k. So v plus 1 plus v square is kx. I can substitute y is equal to vx. So 1 x square plus y square is k over x. So kx square is my right. It's a kx square. It's a ky square. It's a cancel. Ky square cancel. C is my right answer of the problem. Now you can see y is the solution of this. Now it's a constant coefficient. They are asking you about the solution. So what is that? It's m cube minus m square plus 4m minus 4 is 0. Fine. It's again the initial value problem. It's a cube. So 3 conditions are given to you. You will get a unique solution. So what is that? It's a m square plus 4 and m minus 1 0. So my solution will be c1 e raised to power x plus c2 cos of 2x plus c3 sine of 2x. Now, so before applying this condition, remember that before applying this condition, always try to find what you actually wants to find right here. After that we can see. So you can see what is the sine of 2 pi. It will be 0. Fine. It will be minus 1. So it will be c1 e raised to power x, e raised to power pi over 2 minus c2. Now if you look about the option, if you look about here, then your c1 will be, if I compare them, c1 will be here, c2 will be 6 over 5. If I look about here, c1 will be 6 over 5, c2 will be 4 over 5, c1 will be 8 over 5, c2 will be 2 over 5, c1 will be 8 over 5, c2 will be minus 2 over 5. Now we can check about the option. So because c1 and c2, I can firstly check y dash. What is the y dash of 0? Derivative at the 0, c1. What is the derivative of cos is? Sine. So sine of 0 will be 0. It will be twice of c3. But you can see there is no need of the c3. So it means there is no need to solve this. I can check about the y double dash. What is the second derivative of this? Y double dash of 0. Fine. Second derivative of this 0 is my here. What is the first derivative is? Minus 2 sine 2x. Second derivative is minus 4 cos 2x. Add the x0. It's my minus 4c2. This the first derivative will be cos. Second will be sine. It will be 0. So this value is my here. Now check about that which of the following options are satisfied. 4 minus 16 not satisfied. 6 minus 16 not satisfied. 8 minus 8 satisfied. 8 plus 8 not satisfied. Right answer is my C is the correct option. Always remember student, in the competition exam there is no need to solve each problem. There is, look at that, we need a C1 and C2. There is no need to solve them. If you start from here in the examination, like y dash is my 2 and y double dash of 0 is my 0, you will get the 3 equations with the 3 variable. Then you have to find it, but there is no need of them. Look at the only simplest way. Okay, again the initial value problem of now it's a y double dash. Always remember these simple tips. Whenever you have the equation of the x square y double dash plus p x y dash plus y is equal to 0. Fine. Remember, if it is a second derivative, it's a 2. If a first derivative, x raised to power 1. This is called as Cauchy-Euler equation. Fine. So how you can solve that? You can simply solve, you can write it directly here. M square plus p minus 1 of m plus q, if I say it's a q, this is my 0. And the final solution will be my C1 x raised to power m. Fine. And you remember that how I got this solution? I always substitute x is e raised to power z. Fine. Now if I look about this case, what is my p? P is my 0. Q is my minus. Make sure the coefficient of this should be 1. In this case also there. What is my solution is? M square minus m minus 6 0. So what is the roots are there? M minus 3, m plus 2. So my solution will be, m is my 3. So C1 x cube, C2 x of minus 2. Then the value of, now you can see, as x approaches 0, y will also goes to the 0. But if you look about that, if x approaches 0, this will goes to the infinity. So when this condition will be happen, this happen only when C2 will be 0. So therefore, my solution will be cx cube. Fine. Now your target is to find the alpha. What is the y of 1? Y of 1 is my c and it will be alpha. So your target is to find the value of c. I can use this. What is the y dash? 3c x square. What is the y dash of 1? It is my 3c is equal to 6, c is my 2. So alpha is also 2 is my right answer. Always remember this is the Cauchy equation by solving this rule. Again you can see it's a Cauchy equation where p is my -4, q is my 6. So my equation will be p minus 1. P minus 1 is minus 5m plus 6, 0. So your roots are, solution will be c1 x square, c2 x cube. Fine. Your target is to find the y4. So what is the y of 4 is 16c1, 64c2. Now you can find it. What is the y of 2? It is a 4c1 plus 8c2 is my 0. That means c1 is minus, and derivative of this. So what is the derivative is 2c1x, 3c2x square. So derivative at the point 2, it is my 4c1, 12c2 is my 4. I can divide by 4 is my 1. c1 will be my minus of, so c2 will be my 1. Fine, I can substitute this value here. c2 is 1, so c1 will be minus 2. I can substitute here. Minus 32 plus 64, right answer is 32 is my right answer. Look at this another one. Again you can see it's a Cauchy-Euler equation. Fine, but you can see the right hand side is my z. So I can write this is m square, p is my 1, q is my 1. So p minus 1 will be 0 plus 1. X, what I have substituted is x is my e raised to power z. Fine. Now what is my solution is m is plus minus iota. So the solution will be c1 x raised to power iota. That is, you can't write that. So I can see instead of this it will be c1 cos of ln of x plus c2 sine of ln of x. Now can you find the particular integral? What is the particular solution of this? It's a d square plus 1 into e raised to power z. I can substitute 1, it will be half e raised to power z. E raised to power z is x. Fine. Now look at that. I told you, firstly you can find what you actually needed them, pi over 2. So you can see what is the ln of pi by 2? Pi by 2 is outside. Ln of e is 1, cos pi by 2 is my 0, plus c2, it will be plus half e raised to power pi over 2. Fine. Now you can see about the option. So first of all you can see this option is cancelled, this option is cancelled because it is not involved this. E raised to power pi by 2 plus 1. So you can see e raised to power pi by 2 plus 1, and here e raised to power pi by 2 minus 1. So the only option left is B is my right answer. That's the plus benefit of this. If you start from the initial requirement, after that you can substitute here if there is a need of them. So what is the meaning of that? If you apply this condition, you will get C2 is also 1 over 2, but there is no need of solution. Okay, look at this next question. Again the initial value problem is given to you. My target is to find the value of alpha, pi by 2. Pi by 2 is 1.57. It lies here. So I can consider only this case. Fine, because pi by 2 is lies in this case. If any value lies in this case, then you have to consider both the elements. Okay, remember that. If I say, if somebody asks you find the value of 3 which lies here, then it doesn't mean that you can simply take it as a 2. You have to consider both elements. Now can you find the solution of this? M square plus 4 is 0. So my solution is C1 cos 2x, sorry, this is in terms of the t, cos of 2t plus sine of. Now can you find the particular integral? So particular integral is d square plus 4 into t. So since it's a linear, so this will be, I can write an as 1 over 4 is outside, d square over 4 minus 1 of t. So that will be only t by 4, because this value will goes to the 0. So plus t by 4. Fine. Now your target is to find the alpha, that's a pi by 2. What is the value of pi by 2? Sine pi by 2, this is sine pi is a 0. This is my minus c1 plus pi over 8. So it means your target is to find only c1. So which value will look about that? If I substitute y of 0 is 0, cos 0 is 1, sine 0 will be 0, plus 0, it is 0. So c1 is my 0. So what is my alpha? Alpha is pi over 8. So if I substitute here 4 over pi into pi over 8, so that is my answer is 0.5 is my required answer of this problem. I again told you, whatever you want to find, firstly calculate this instead of applying these conditions. There is no need to apply the conditions. If we whatever we require, we can solve that. Okay, look at this another case. The initial value problem is given to you, and which of the following options are? Look at that. My right hand side is e raised to power minus t sine of t. Fine. This will part of the particular integral, and you can see about the solution. These are also my particular integrals. So it means it must be of the form e raised to power minus t sine t. But you can see this is not the form of this. It will be cancelled out. You can see here, this is also not the form of this. It is again cancelled out. Fine. Now you have the two options. So I can find the particular integral firstly. What is the particular integral is? It's a d square plus 2d plus 5 into 3 e raised to power minus sine t. I can take 3 is outside, e raised to power minus t is outside. So it will be d minus 1 whole square plus twice of d minus 1 plus 5 of sine of t. So what is the right answer of this? If you simplify it, d square plus 1 minus 2, 6 plus 4 minus 2 cancel out, it is a plus sine t. So if I substitute here, it is a minus 1 plus 4 is a 3, it will be cancelled out, e raised to power minus of t sine t. This is my pi. Okay, can you find the complement homogeneous part? M square plus 2m plus 5 is equal to 0. So m will be minus b, because e raised to power minus 5t in the both side. So plus minus b square minus 4ac over 2. So minus 1 plus minus is a 16. 4, it will be the 2 iota. Fine. So the solution will be c1 cos 2t plus c2 sine 2t into e raised to power minus t. So my solution will be this plus this. But if you look about the option, there is no cosine term. That means c1 will be 0 if I apply this condition. So my solution will be e raised to power minus c2 sine of 2t plus e raised to power minus. Now clearly says c2 will be non-zero, because if c2 will be 0, this homogeneous part will completely be the 0. So that means this is my right answer. This will not be the right. Or moreover, if you want, I can check it by using this one, because now my solution, complementary solution will be c2. Now here I can apply the derivative at the point 0. So if we apply the derivative at the point 0, what will happen? c2 first value will be 0, it will be my plus 2, and then it will be the 0 plus 1, it will be my 3. So what will happen is 2c2 is my 2, c2 will be my 1. So c2 is 1, it means the right answer is B is my correct answer. Look at this another one again, which is the initial value problem and the Laplace transformation of y. Okay, there are the two ways. Either you can start with the Laplace transformation of this starting directly, otherwise I can find the homogeneous solution as cos of x plus c2 sin x. Fine. What is the particular solution is? D square plus 1 6 cos of 2x. So I can substitute here is minus 4. Minus 4 plus 1 is minus 3. So it will be minus 2 cos of 2x. Fine. This is the solution of here. We will apply later on. If the Laplace transformation of y is, so I can find the Laplace transformation of y. What is the Laplace transformation of the y? This is my c1 s over s square plus 1, c2 over s square plus 1. It will be my 2s over s square plus 1. Then your required target is to find the values at 1. So it will be c1 over 2, it will be c2 over 2, it will be 2 over 1 plus 1 is 2. Fine? No, sorry. C1 of s square plus 4. So it's a 2 over 5. Now your required target is to find the C1 and C2. Now your solution will be here. Fine. Now what is the y of 0? Is 3. So what is the y0? This value will be 0. This value will be 1. This value will be my 2. This is my 3. So C1 will be my 5. Fine. Now you can find the derivative at the point 0 is 1. If I take the derivative of this, it will be 0 at the point 0. This will be my only C2. This derivative will be my 0. So C2 is my 1. So if I substitute here, 5 over 2, 1 over 2 minus 2 over 5. So 3 minus 2 over 5. 15 minus 2, 13 over 5 is my right answer of the problem. You can see how many seconds you are needed to solve this. What I wrote, 1, 2, 3, 4, 5, maximum 5 lines. Okay, the initial value problem is given to be here is a Dirac delta function. Fine. You can check about the initial condition firstly. Y of 0 all are satisfied. Okay, y of 0 is 0 and y dash 0 is 0. Can you find any of the solution based on this condition? There is no solution. Fine. Because I think there is a misprint in this gate examination paper. It must be the non-zero. Anyhow, I can check about this. What is the derivative of this? This plus 3 to the 6 e raised to power t cos of 3t. Clearly say this will 0, but this will be my 6, which is non-zero. This option cancel. Similarly for here, what is the difference between them? Here instead of the 2 is my 6. So instead of here it will be my 3 times. Again it will not be satisfied. It will be my e raised to power. So I can take that derivative. It will be my minus sine of 3t. And then it will be the plus 6 e raised to power minus cos of 3t. So clearly say this will be my 0. This will be 6, which is non-zero. So this option will also cancel. Again it is a similar of this, only difference is constant. So none of these is my right answer. I think that is the only problem about here. Y dash 0 should be the non-zero. Otherwise the no solution will be appear. Because why is a no solution? Because as I told you in the initial one question also, these are my continuous function. Fine. So it means it has a unique solution, but you can see there is no y which satisfies both the condition at the same time. That's why no solution. Okay, look at this one. If y is the solution of this problem satisfying my here, the largest interval to the right of the origin. You can see, if you think about, you can solve like this manner, a over b by m, you can solve it, but we need a largest interval right of the origin. It means this condition will work on that, because this is the only initial condition right of the origin. So I can think about, I can solve this problem by firstly think about here. Fine. Now I can simply take y is equal to z square. So what is that? It's a 2z dz over 2 1 plus z square into z is a dx. Fine. So this will be cancelled out, z will be cancelled out. It's a tan inverse z, and z I can substitute from here is root y, which is x plus c. So what is the meaning of the y is tan square x plus c. Fine. Now since I need to find here what is the value of the y, pi by 2 is 1. That will give you 1, which is equal to tan square pi over 2 plus c. Fine. Now when it will be 1, when this value pi over 2 plus c will be my pi over 4, but because of this plus minus I can say it's a plus minus, because it's a square, it can be plus or minus 1, or you can say either as a 3 pi by 4. It's on your choice. Fine. So if I see here, then c will be my plus minus pi over 4 minus pi over 2. Fine. So if I choose as a positive value, then pi over 4 minus pi over 2, or it's a minus pi over 4 minus pi over 2. So what is the answer of this? 4 is the LCM, minus pi over 4, and from here it's a minus 3 pi by 4. I can ignore the negative sign, otherwise you can take as a 3 pi by 4. Fine. So my interval will be 3 pi by 4 or 3 pi by 4. So which one is the right of the origin? So 0 comma pi by 4 and 0 comma 3 pi by 4. You can see. So 3 pi by 4, the length of this is the largest one. So that is my largest answer of this problem. Fine. And you may see that at the pi by 2, this value will be my 1. At the 3 pi by 2, this value is also my 1. So that's the way you can solve this question in a simple manner. So I can choose this value or this value. I can substitute here. You can check whether it's a 1 or not. Okay, look at this one. Y is the initial value problem, and they are talking about the initial. Okay, this is a numerical analysis, but anyhow, because of the initial value problem, I consider this. So what is the Taylor series? Taylor series at the point A is h over 1 factorial y dash at the point A plus h square over 2 factorial y double dash at the point A. What is my A is? Initial condition 0. What is the h is? The difference 0 and here. Fine. Now what is our x is? I need to find the value at 0.1. So what is the y of 0? Y of 0 is 1. H is my 0.1 over. What is the y dash of 0. What is the y dash of 0? So clearly say y dash is here. So can you find the value of the at the point 0? So what is the y of 0 square plus 0? So what is that? It's a 1. H square 0.01 over 2 factorial. What is the y double dash? So I can find the y double dash from here. So it will be 2y dash plus 1. So what is the value of the y at 0? So 2 into what is the value of the y dash 0? 1. What is the y dash of 0 is again 1 plus 1 is a 3. Fine. Now you can see it's a 1 plus 1 over 10. Sorry, it's a square. Yes. So y double is a 3 by 2, 1.5 over 100. Now if you take the LCM, it's a 100 plus 10 plus 1.5 over 100. So it's a 1.5 over 100. So what is the right answer of this? 1.115C is my right answer of the problem. Okay, look at this another one. Again, this is a numerical analysis problem, but because of the initial value problem, I consider here. It is given as a second order Runge-Kutta method. Do you know what is the second order Runge-Kutta method? It is called as the Euler method. Fine. So what is the condition of what is the Euler method is? Y of I plus 1 is y of I plus k1 plus k2 divided by 2. Make sure where k1 is my here and k2 is my this. So whenever you apply the Runge-Kutta method, make sure the coefficient of k1 plus the coefficient of k2, it must be 1. That is the most important condition. You can see here half plus half is 1. Again you can see from here half plus half is 1. But you can see it's a half, but it is not a half. Okay, another concept from here is whenever you have taken the k1 and k2, in that case this alpha coefficient of the h and k must be same. Fine. And your target is to find the alpha beta. That means my target is to find the alpha square. Now, what is the journal formula for the Runge-Kutta method? I will tell you the journal formula. So y of I plus 1, which is equal to y of I can written as a y of I plus k1, coefficient is 1 over 1 minus 2 alpha plus k2 of 2 alpha. Make sure the coefficient of this and this should be 1. So you can see it's verified. So if you compare this equation by here, what is the value of 1 minus 2 alpha? 1 over 4. 1 over 2 alpha is my 3 over 4. So you can find its value simply. What is the value of the alpha from here? 2 over 3. Once alpha will be my 2 over 3, beta is also 2 over 3. So the right answer is 4 over 9 is my right answer of this problem. So you can see it's a very simple approach. You can solve this with the help of this initial value problem concept. Always remember that always apply the initial condition later on and the whatever you want to find as a firstly. I hope you can simply remember these tricks for solving the coming examination paper. I will solve the next lecture on the solution of the differential equation like second order differential equation and higher order. Till then you can simply like, share and comment on video. Best of luck students. Happy learning.